Hey, we're live.
Yeah, you're finally live. Hello,
Awesome.
everybody. Just us, Leo. Uh, one more Java video channel here. So today we're gonna talk about NoSQL API database, and of course the graph database. That's a kind of NoSQL database. I'm here with Leonardo Lima. Hello, Leo.
Hello, I'm Leo. Nice to meet you guys.
Yeah. So, man, please introduce yourself. Then you can start.
All right, so I'm Leonardo Lima. I am a CTO at V2Com, and I'm from Brazil, but I'm currently in Austin, Texas, where I'm just closer to the technology. For my company, I am the executive committee representative for the Java community process. So we joined the GCP a while ago, and I'm also a committer on the Eclipse JNoSQL API, and I contribute to Eclipse collections as well. We're also part of the Eclipse Foundation as a solutions member, so we're really tight with Eclipse and the JCP. So
Oh,
the
nice, man.
Yeah, so today we are about to we're gonna do a talk that we did on Java 1 last year, where we explained how we were using the JNoSQL API for solving a problem with NoSQL databases. So I think I could start already. So if anyone has any questions or anything, you can just send me or Otavio an email or write down in comments or send us a tweet. We can begin as soon as I press share. Share screen. Share screen. Woo! So hopefully guys can see my screen now. And we're gonna talk about
Yes, we can.
yes. So the title of the talk is choosing an NoSQL API and database to avoid tombstones and dragons in Game On. So we're gonna talk about the use case and how we use JNoSQL to solve the problem. Tavio here with me, and also Kate, who isn't here with us today, but she presented with us on Java 1 2017, the last Java 1 there was. So as I said, I'm from Brazil. I'm a computer engineer, and I've been doing IoT development for more than 10 years. I did some JSRs. I did talks, and I also go for Eclipse projects. Currently, Eclipse collections, Eclipse JNoSQL. Otavio is a software engineer with Summit Tribe from Brazil as well. And we're both Java champions. I forgot to mention that. And he's been doing this. He's a kind of the flag man for the JNoSQL Eclipse project. So props to him. So I'm gonna talk. I'm gonna introduce the use case that we're gonna talk about. Is a game developed by IBM called Game On. So why Game On and why it has microservices in Game On? Microservices are really quick into because it's been talked ad infinitum already. So microservices are used to compose a complex application using small, independent, replaceable processes that communicate via language agnostic APIs. So nothing new here. And so if you go for you're a newbie, right? You don't know what microservices are, or you just heard about it and you didn't have a chance to test it out yet. So you go online and go on Google. So I want to create a single service or create a microservice, and everywhere you're gonna find either a single service. So you create one service, and that's kind of not the goal for microservices, right? Just some single microservice doesn't do anything good by itself. It has to be a part of an ecosystem. And also, you can also find pre-baked microservice applications. So that would be, for example, here on the Bluemix, they have a download, some click, next, finish, and you get a bunch of microservices. That really doesn't teach you how microservices work and what you're going to do with it. So they say microservices are easy, and it really goes all the way through the curve of your start clueless, get confident, and then when you really really get your hands dirty, you see that's harder than you thought, and then the challenges are real, and then as you go, you get more experienced, and you understand because you made it work. So Game On was developed by IBM, as I said before, to be a place where you can mess with microservices in a fun way, more complete than just a hello world, but as simple as a hello world application, and where you can do your room for this game, and then you start learning and you go as you need to go. So the idea is that you can completely change how this game works, and the basic infrastructure is already there for you. So besides using microservices and being an inspiration for microservices, they also did a very good job to consider the 12 factors, which is a methodology for building software as a service applications created by developers at Heroku. And they have the 12 factors are listed here, and there's a link if you guys want to follow later on. It's 12factor.net. I'll not just read all of them. It's just a good way that they did this development, and I think it shows the value that IBM is doing with this. And props to IBM. And I met them 2 years ago, and it was really interesting to see what they're doing. And I got excited, and we got our hands dirty with not just creating a room, a microservice, but also changing the back end of some of the things here. And so a little bit of the history of Game On. So Game On at first was very simple microservices, right? It was just a proxy that has the three services: a room, which is what you create as a student on Game On. You create rooms, and then you navigate through rooms, kind of in a mud, like those throwback RPGs, text-based RPGs that you used to play on the BBS world way back then. So there is a room that is a microservice, or plenty of rooms. The more rooms, the better. And also there's three microservices maintained by the infrastructure team, which is a proxy, player, and concierge. And they were using OutStack for logs and all that monitoring that they had on the services, and also writing stuff down to MongoDB. And then really pretty soon it evolved to something more complex. So I'm not going to go over all the services here, but you can see it's much more busy slide than it was before. And I want you guys to notice these changes. So before it was a MongoDB database, and now it's a CouchDB database. And you have two services talking to a database. They don't share data; they just use the same database type. And now the problem is, if you want to change this now to a second database or to a third database for any reason, you get to rewrite all your code and all that stuff. And that's part of the problems the API is going to help you solve. So, and going back to the title of the talk, which is the Dragons and Tombstones. So the problem we're trying to solve, going back one slide, you see one of the circles is on the map microservice. So on the map microservice, we want to have the map center around a room, the first room. So when you start the game, you land on the first room, and the first room is always there. And as people add more rooms, you go and you want to add these rooms in a 2D grid, very densely, tightly packed grid of a Cartesian map. So it's X and Y. And then you see the colors as they go away from the center. You can see different colors and all that. It's easy to render as well. If you try to render a 3D map, it's harder as well. So the problem, the use case we're trying to solve with the map microservice is maintaining a center densely packed grid of rooms. And we can do this with many choices, and SQL is hard, and it's something from the old days, and we don't want to use this. So CouchDB was used already for the player database, and they said, well, we can store this with JavaScript with custom indexes, and we can just store the rooms. And this is what the developers that were doing these hiring she used this because she knew CouchDB, right? So I said, well, let's go and use this. And at first, everything looks fine. But the problem is when you delete a room, for example, if the microservice is offline for 7 days, you want to delete it. It lives back at Tombstone, and that's terminology for the CouchDB. So when you delete something on CouchDB, really don't delete it. And maybe they do it now, but they didn't back in the day. So that's pretty much the use case. And because we're talking microservices, we have a map API which lists the services that we are serving to others. And so it has a pretty much CRUD like get, put, delete, and post for creating, deleting, and all that with a room. And the idea is that you can, what is really interesting is the list all the sites and giving a room, what's the neighbor information. So from a room, you can go to north, west, south, and east locations, and pretty much the navigation then is handled by the other services. But the map is responsible for storing the relationship between every room. So as you now here is an example of a room. So it has a name and has connection details. So how do you connect to that microservice to serve the room? And the name and the doors on the middle there on the slide shows the description of the doors of the room going north. If you're entering this room, the first room from the north, west, south, and east directions. And because it's microservices, you normally don't care about the internals of the service. But now, because we're messing with the map service, it's worth mentioning how it works and how that's the problem and how we solve the problem. So today, the microservice is literally a copy of what what is exposed on the API. So if the person does a post, there's some checks, and then it's stored like that. Because it's a document, it's hard to store references to other rooms, and there is no really way to guarantee the links and all that. And because we were trying to do the centering stuff the way it was done before, it required a room per location. And because there was no really way to delete a room, it also got really problematic when people got notice of the Game On. So lots of rooms, and IBM does a lot of workshops with NX and trade shows with this service. And so a bunch of rooms are created, and there's really no way to delete rooms after the people lose interest or lose their rooms. So I was talking with Erin about this, and when I've been working with maps, not Game On maps, but I've been working with maps, geographical maps for a while, and I really thought, well, maps you can think of maps as a graph, because a map is a collection of rooms connected through doors, or a collection of places connected through roads, or you can do pretty much a representation of a map with a graph. So graphically, it looks like this. So you have a map that has a very ABCD as cities or locations or end nodes on a Wi-Fi mesh network, for example. You can see how they are connected in a graph. And when I told her that, she said she was really excited and said, well, okay, but I don't know anything about graph, and can you help us with that? And also, we have to change everything again. So I said, okay, let me show you how all it really looks, right? So so we have for example, the first room. The first room can have a basement, like the second room is going to be added. And then you can have a playroom and a dungeon as well. And you can do the doors and locations between all these places. So it fits the purpose really nicely. And why we think that that's a good thing? Because then you can expand, right? I'm going to cover why being a graph also adds more value than just being a nice representation of the map. So we did the first time I started messing with the code, and I didn't finish it through because it was really in the end. It was more cumbersome than I thought it would be. I just took Neo4j, which is a very popular graph database, and I started doing kind of the same thing that we were doing with CouchDB, but with Neo4j, right? And the problem was to do the CRUD operations. It was I had to do the conversion from Cipher through object and back and forth through using inspection, and it was really not something really nice. My experience with Neo4j was not that great as well. So I said, well, if I really want to do this with Neo4j, I will have to go deeper, and then I'll have the same problem as we had before with CouchDB, right? We're going to be locking ourselves down to someone else. So in the end, just changing who was holding our chain. So before it was CouchDB, now it's going to be Neo4j. So I'm talking with Otavio back then. He said, well, we're doing this NoSQL database APIs. And I said, well, maybe that's something we can work with. And we got really excited about it and we discussed. And here we are presenting about how we're going to use this new API to solve this problem. So at first, let's see what NoSQL is, right? NoSQL is two different layers with APIs to do the mapping and communication with different database NoSQL database types. So the idea is to avoid lock-in and to have a divide and conquer approach on let's focus on what each layer has best and what each database has best, and build something that is easy to use after you join all the modules you need. So the name of the mapping layer is Artemis, and communication layer is Diana. So Otavio is really high on Greek mythology, so that's pretty much where the names came from and the examples also came from. The idea is that you use the NoSQL database as your DAO layer. From your DAO layer, you just map directly to your database. It's an Eclipse project, so it's still incubation, I think, but it's an Eclipse project, upcoming Eclipse project, licensed under Apache v2 and also EPL 1.0. There is an API for each NoSQL type, and I'm going to cover this on the communication layer. It's highly configurable and highly extensible. So we have 4 different database types, right? Key value, document, and column family, and graph. And because there is no approach for the key value, document, and column family yet, like a standard or anything like a good library for covering kind of any of these database types, we're developing new APIs for those. But for the graph database, we're reusing what Tinkerpop project, Apache Tinkerpop project did. It was a really good project, and we're going to use that as a starting point for the graph database. The NoSQL starts off in a very good place, because even though there is no really NoSQL APIs, there is SQL APIs, right? There is Hibernate and JPA and also different mapping ORM libraries. And while the ORMs currently today are not suited for NoSQL databases, the annotations are. So we're trying to do everything as standard as possible, and trying not to reinvent the wheel and go over the good things that we have in the community already. So we have annotated entities. We work with templates, repository, and configuration, pretty much the way other projects work, like Spike and as I said, Tinkerpop. An example of annotated entities that really could be taken from a JPA talk is like if I have a site or room, we can have it as marked as an entity. You have an ID and have a column. And this column is just an attribute, right? It doesn't have to be a real column on a SQL database. It can be an attribute on a JSON document if it's the document DB. And the idea is, again, we have these annotations that were already defined. People are used to it. And someone that knows JPA can really start working with NoSQL without much trouble, right? It just starts coding away. Again, template, it's a feature that you can just start writing your queries, not your SQL queries, right? Your queries. In this case, is a graph database, so it's a graph template. You do a traverso, and here we're getting a recent room, the room that is inserted not so long ago, and this is searching for graph that has the attribute door available marked as true, ordered by the weight, where is the way that we thought about centering the centering problem was just add weights to the rooms, and so we have the order by weight, and then you get the first one, and there might be no sites available, so there's an optional site. So it's really readable, and it's really easy to build your queries when using NoSQL. And for the repository, it's also the same idea. You can just define an interface where your repository, for example, is a site and long is the key. And you can have a method find by name, and automatically it will read this, interpret this, and you don't even have to implement this site repository implementation like you used to have on JPA1, right? You just say add inject, add database graph, and then it's a graph database. It's going to be added there. You don't have to worry about any of the internals. The API will do it for you. And for example, I see this being done in Delta Spike as well, which is a really good database interaction API for SQL databases. So it's really good inspiration for us. The transactional aspects of a database can also be seen here. Of course, if the underlying database doesn't support this, there is no use of you doing this annotations. But if there is support, you can leverage transactional support. And again, because this is an extensible database, the API, we can the users or the vendors can define new annotations that will take place when their databases are being used. And that's the power of having an API that is extensible. You don't lock people in beforehand on what they can do and what not. So if the save database, for example, here's a save method, then we can do a find by name, and if it's present, I will merge what I had before, and then I just do a repository save, and the find by name can be just repository find by name if I want to have a method abstracting the repository. So that was a quick recap on NoSQL. We have, I think, a talk already recorded on the YouTube channel about NoSQL. We can always update it if you guys wanted to, but we did it recently. I don't think there is any new developments like new features. It's a really good introductory talk about NoSQL, so that we cover more aspects of the database there. Again, when I was explaining how the game room situation, the Game On map situation, I showed you that the graph solves other things as well. So why a graph is good? Talking to the guys on their Select channel, the guys that run the Game On, the team behind Game On, I must say, they said, well, they want to do other things. They want to have objects that can be tracked. They want to have more than just 4 doors, right? If you can have more than just northwest, south, and east, you can have up, down. You can have north by northwest or south by southwest. It doesn't matter. With a graph, you can have an infinite number of pointers between these objects, and with a graph that looks like this from the first slides I was showing this, we can add, for example, a ring that is being tracked to the playroom, and then if someone moves the ring, you can just update this later on. And also you can have a trapdoor or secret passage that goes from the playroom to the dungeon, and it's not listed. It's not easily listed. You can just go. If you search 3 times, then you find it. So depending on the room, you can really add more features to it if the map supports easier navigation. You can also have the concept of suites, where you have the basement, for example, going to a set of rooms that are linked together, and they can only go in that given way. And the basement doesn't know about it, and the other services don't know how to know about it, but the suite service does. So if the map has information about this, the room maintainer can inform the map service, hey, this is my suite, this is the graph, this is the only doors that are available for you. This talk is an introductory talk. We do have some source code to show you guys. Tav is going to show next on how we used. But also, please do get involved. And there is a gameontext.select.com. That's where the conversations happen. The team that develops Game On is eager to help and eager to accept ideas for new features. The site where you can go and play Game On is gameontext.org. They'll have our NoSQL.org website as well. That's where the project is hosted. And the implementation that we did is posted on my GitHub. It's github.com/LeoMrLima/GameOnGraphMap. That's pretty much it. I don't know if you have anyone online asking questions. Otavio, do we have questions?
No, we don't have any question.
All right, so maybe it's time for you to show the source code then. I'm stop sharing my screen, and now you can share yours or show our source code and wherever it is.
Okay, thank you, Leo. Nice introduction. So, can you see my screen?
Yes.
Okay, nice. So the first thing is to show the model that you have here. We have a couple notation. So we have at entity, at ID, at column. Everybody who knows JPA, you won't make difficult to understand NoSQL. As you can see, the annotations look like JPA. However, it has a different quality field. It has a different package name. So everything's come from NoSQL package. So we have the site here. So the column to column, ID to add ID, and that we have to site, because a run is a place, right? So it's a site.
Yep.
You have the coordinate that's an embedded field that has X and Y field on the coordinate, and that we have. And if you go deeper here, as todos, we have the first guy is the site service that inject a graph template. That's the first guy. What is a graph template? I believe everybody knows what is template method from design partner. That is exactly mindset. So it's a kind of template method. However, instead of code, we have the template method to graph database operations. So we can do query, you can do a lot of stuff, as Leo told us. However, what we have here, it's a different kind of query. That's a Apache Tinkerpop query. So as you can see here, you can get the recent room. So we order by weight and check if this guy is available, and you just return just one element. And also, imagine right now we are in the main room, and then you'd like to go to another room. So give the room here, the site room, and you'd like to go to direction. So what are you doing right now is navigate through the rooms, right? So the direction here, it's NN. So we have the element unit element here. So north, south, east, west. As Leo already mentioned, you can put 3D direction here, so you can put more and more element here to do the scan. You can go up, down, and wherever you want. You can go through the secret door. That's
Yeah,
everything
and
I have here.
normally,
So
yeah, because we're trying to do just a background conversion. Let's say we just wanted to change the internals before, so we kind of kept the same ideas of northwest, east, and south. The idea is that this enum can go away after, and then can be any direction that the developer wants, right? So for now, this is just one way of keeping the same external API and changing the internal way of working.
yeah, good point. And also, what I have here is okay, the site repository. So basically, this guy here is just an interface, as you can see here. If you try to find any implementation, I won't find it because basically the general SQL framework gonna handle to us. So what I have here are some methods that is the save, just an entities, save a lot of entities, delete by ID, find by ID, and also what you can do here is method by query. So basically, I just write down my method, and then the GNOC gonna handle to us to implement this method. So right now, what you'd like to do is give the site I'd like to find by name, and that's the whole point, right? So let's return to the site service here. That's the guy here. So basically, I find by name, and then if this guy already exists, I do a merge, and then update the site. So this repository here follows the DDD. So basically, what it's gonna do is, if this guy's already exists in the database, it's gonna insert or it's gonna update. Otherwise, it's gonna to insert in the database. So basically, it's gonna try to find by ID. So the guy who has the ID annotation. If this guy has the ID annotation, you're gonna find it by this ID. And if it does exist, gonna update. Oh, otherwise, it's gonna to update the information. And also here, just to make easier to run the code, we create some unit tests here. So as you can see here, so basically what I have here is JUnit, the latest version. So I just inject the repository here. As you can see, there's no implementation of this guy here. So I will run this guy. I try to find someone, and basically that's the whole point. So basically, what I'm gonna do is try to run uh, this unit test. Use an extension to that basically use CDI 2.0. Oh, by the way, let's show the panels. So I have the graph, the panels, the configuration, that inject any configuration. And of course, you have the Grammarly core. So basically, the Grammarly is the communication API to GNOSQL on the graph aspect. So that's what we have. The integration to the Java EE, the latest version, the unit version, and just to test, you're gonna run the wells uh, 3.0.3 version. Well, is the reference implementation to CDI. Okay, let's run this guy here. And run. And basically what I have here is the CDI is going to inject this repository and then do any operation. And that's what I have to show you.
Nice. So you guys, can you share screen go again, just real quick? Just so I want to point out some extra.
Okay.
Yeah. So as you can see, it's really easy to use the API with the common-based annotations and also embedded tests. So you don't have to run. You can run this against an existing database, or you can run your graph database in memory as well. And with just some basic annotations, you can start working with this and maybe take your GPA code and change the underlying annotation, underlying database implementation, and be instead of just using SQL, now you're using general SQL. You get a document database, and maybe you're just right away. There's some annotation that doesn't make sense depending on the database type you choose. So there is no foreign key, for example. ID code. This concept doesn't exist in a general SQL world. I would say that some adaptation might be needed on major projects, but your pet project that you have for JPA, for example, you can really test general SQL out just changing some dependencies and some Maven dependencies, right? So please take for a spin. Test it out. We need use cases, and we need people testing it out. Shout at us on Twitter if with questions or any other ideas that you guys see that are missing, and we can go after and do them for you. So I think that's pretty much what we had for today. If there is no live questions, I think we can end it out, right? Yep.
Yeah.
So thanks very much. Thanks, Otavio, for showing us the code. And thank you, IBM, for having Game On. It's really a good platform. And thank you, Eclipse, for hosting us. And so Java is our user group for Brazil. So this was a South Java presentation. We're going to be doing more talks on QCon São Paulo on about this topic as well. So if you guys are interested, I'll be there with Otavio, and more also talks during other events throughout this year. So it's really picking up, and I'm really excited about the future. Hey, thanks very much. And that's pretty much it. Bye, guys.
Yeah. Bye, guys.